So there's definitely a couple of ways, at least a couple, that you could solve this. Whenever I see a parabola, any quadratic expression, and I'm dealing with something to do with the vertex, I want to try and take advantage of something that I have memorized, and you hopefully do as well, which is that the x-coordinate of a vertex for a parabola that's given in standard form, and as a brief reminder, standard form is ax squared plus bx plus c, and this one is given in standard form. Then the x-coordinate of the vertex, I'll say x vert, is equal to negative b over 2a, all right? So one of the ways to go about solving this is to recognize that, well, okay, I have a, right? I know that a is negative 14 based on the coefficients in the given equation. And so given that I also have the x-coordinate of the vertex, I can easily solve for b, right? So the x-coordinate of the vertex is 9. That's got to be equal to negative b, so that's going to be negative b. I'm trying to solve for b, divided by 2a, so divided by 2 times negative 14. All right, so if you go ahead and solve that expression for b, right, b is going to be equal to, it's going to be, 18 times 14, and so we get 252. Okay, b is equal to 252. Now at that point, my original equation is y equals negative 14x squared plus 252x, and then plus c. And at this point, because I have a point, right, 9 comma 2, I can just plug in 9 for x, plug in 2 for y, and see what I get for c. So I'll say 2 is equal to negative 14 times x, which is 9 squared, plus 252 times that 9 plus c. So I'm going to go ahead and say, all right, 2, I'm going to add to that 81 times 14, right? 9 squared times 14. And I'll subtract from that 9 times 252. So what I get at the end of that is that c is equal to, and this is just algebra 1, I hope you can do this part, negative 1132. All right, so my parabola, well, actually, it's just find b and c. So here's b and here's c. Right? And the equation would be y is equal to minus 14x squared, and then plus 252x minus 1132. Now, there's quite a few other ways that you can go about this. And in a testing situation, if you've not remembered this pretty helpful piece of information, then you need to have some other kind of tricks up your sleeve. So another thing you might want to recognize is that we can repurpose our standard form of a parabola in vertex form, right? Some constant a, and those a's are the same, x minus h squared, and then plus k. All right, so hk, this is vertex form, hk is your vertex. So we know here that h is equal to 9, k is equal to 2. So we'll take advantage of that, because if I have negative 14x squared plus bx plus c, well, that's got to be equal to negative 14 x minus 9 squared plus 2. Now, when I go ahead and FOIL this and multiply out, obviously the negative 14s are going to cancel out, but whatever my coefficient on the x term is on the right side has to equal my coefficient of the x term on the left side. So I can solve for b that way. And the same thing, whatever the constant term on the right side is, that's got to be my constant term on the left side. So I'll go ahead and do that foiling. I'll get negative 14. That's going to be x squared minus 18x plus 81. Plus 2. So when I multiply that out, of course, again, negative 14x squared. We know that 14 times 18 already is going to be 252, so 252x. And then we saw already 81 times 14, right? And then plus 2, that's going to be equal to negative 1132, okay? So you can go ahead and check that math on your own, but that means this is B and this is C. Okay, so those are a couple of ways of going about it. There's a few other ways. You could even actually use quadratic formula if you wanted to, though that would make it, I think, a little bit more difficult. This equation comes from quadratic formula, right? The x-coordinate of the vertex, that's actually just the average of the x-intercepts, right? So if I set this expression equal to 0, I know x is equal to negative b plus minus square root b squared minus 4ac. That's your quadratic formula all over 2a. So I know that the average of those two is going to be the sum of these divided by 2, right? Well, if I take the sum of the roots, then I get negative 2b over 2a divided by 2 gives me the average, negative b over 2a. And that, of course, is the x-coordinate of your vertex. Anyways, Here's your b's and your c's. Hopefully that makes good sense to you.